Okay, let's wrap up this review document in this video. And in number 14, we were given f of x, we want f prime of x. And again, the trick is to realize what we got to do here. So notice we've got an x in this quantity, we've got an x in that quantity. We're multiplying, so we're looking at the product rule, and because of that exponent, we're looking at the chain rule when we take the derivative of the second term, okay? So we've got both product and chain here. Okay, taking the derivative of the first quantity I'm calling u, that would just be 1 times the second quantity I'm calling v. Okay, now I'll keep the first quantity, and now I'll multiply by the derivative of this, and again, that's where the chain rule is going to come into play. So I'm going to bring down the 3, leave the inside alone, subtract 1 from the original power, and now multiply by the derivative of the inside, which would be 2x. Okay, maybe clean it up a little bit, looking at our answer choices here. We're going to have x squared plus 2 cubed plus, if I simplify, that's a 6x, then the x minus 1, and this quantity squared. And part of the trick to multiple choice is being able to match the answers. It looks like our answer choices are all completely factored, okay? So let's try to do that. As I notice, there's two terms, okay? This is one term, this is one term, and they both have that quantity, x squared plus 2 squared, as a common factor. So I'm going to factor that out here. And so I'm going to be left with one more of these x squared plus 2's, and then a 6x with an x minus 1. And now I'm just going to go ahead and clean this up a little bit, see what we get. Okay, I just distributed there, and I'll combine like terms. And let's see if that's out there. Sure enough, it is. Choice D. Okay. So product and chain, and a little bit of simplifying at the end here. Okay, another limit question. As x approaches 0, what does this approach? Well, if I plug 0 into the top, I get 0. When I plug 0 into the bottom, I get 0. So again, I don't want to ever write equal 0 over 0. That's impossible. Nothing can equal that. So I use arrows to indicate that this approaches 0 over 0 and is an indeterminate form. Unlike the definition of derivative limit we saw a little while ago, this can be done algebraically by simply factoring. Let's see. I can factor out an x squared from the numerator, and I can factor out an x squared from the denominator. And so those go, and now when I reevaluate, plugging 0 in for x's, we get 8 over negative 16, negative 1/2 it is. Okay. Next up, if f of x is the cosine of 3x, what is f prime of pi over 9? Okay, so since this is more than a plain x inside the cosine function, we are looking at the chain rule. Outer function is cosine, so f prime will be negative sine, leave the inner part alone, the 3x. Now I'll multiply by the derivative of 3x, which is 3. So I'm going to write this as negative 3 sine of 3x. And now we want to evaluate this at pi over 9. So negative 3 sine of 3 times pi over 9. Okay, well this will simplify to pi over 3, which is an angle we're familiar with. And pi over 3 is the radian measure for 60 degrees, which is the first quadrant, and the sine of 60, of course, is radical 3 over 2, so we get negative 3 times radical 3 over 2, and looks like right there, choice E. Okay. All right, number 17, another kind of a tricky one, and it is chain rule. That's more than a plain x up in the exponent, okay? If it helps, you can rewrite this, e, and then the exponent I could write as 2 times x to the negative first, and that will allow me to avoid using the quotient rule when I go to take the derivative of that portion, okay? So, again, this is chain. E is the outermost thing, so the first derivative I get back exactly what I started with, e to the 2 over x, or e to the 2x to the negative 1, however you want to write that, okay? Notice in your answer choices, they're all written with that, basically that original 2 over x, okay? Now we got to multiply by the derivative of the exponent itself, okay? So this is what I now need to take the derivative of. And that's just power rule. I bring down the -1, I'll get -2x to the -2nd. And there's your whole derivative. And once again, we got to match it up to the correct answer choice, okay? So this portion, I'm going to leave this alone. The portion I boxed in, I could write that as -2 over x squared. And there they have it, choice D. They just flip-flopped the terms. Okay. All right, number 18. If f of x is x squared plus 2x, then find the derivative with respect to x of f of ln of x. So again, this is a composition. We can use the chain rule, but it's going to be a little tricky here. What I would recommend doing is, again, figure out what f of ln of x is here, like we did with f of g of x earlier in this packet, okay? If f of x is x squared plus 2x, then f of ln of x, I'm replacing x with ln of x. So we're going to get ln of x squared plus twice natural log of x. That's what f of ln of x would look like here. And so now if I want to take the derivative of this thing, okay, I don't really like the way that looks. Okay, basically I'm going to take the derivative of this. I'm just going to write that d dx of this. All right. Clean that up a little bit. Okay, so I want the derivative of this. Well, look, we have a quantity raised to a power. That's going to be the chain rule. Bring down the 2, leave the inside alone, subtract 1 from your power, times the derivative of the inner function. The derivative of 2 ln of x is just 2 times 1 over x. So there's our derivative, which I can write like that. Excuse me. And in our answer choices, let's see. Notice these are a common denominator, so we can put those together as a single fraction. And there it is, choice A. Okay. Okay, 19. If sine of xy equals x, find dy dx. Notice the y is kind of buried in the middle of this. This is going to be implicit differentiation with a chain and product on the left side. That's more than a plain x inside the function. That's a chain. We're multiplying x and y. That's a product. Outer thing is the sine function. To take the derivative from left to right, let me get rid of this, okay? From left to right, we're going to get cosine, leave the xy alone, times, now we go inside and take the derivative of x times y. Product rule. The derivative of x is 1 times the y plus, keep the x times the derivative of y with respect to x, there's dy dx. And then the right-hand side, the derivative of x is just 1. Okay, and now our job is to get dy dx all by itself here. There's different things we can do. I could distribute this cosine through. I can actually divide both sides by cosine xy. That's what I'm going to do. When I see 1 over cosine, I do think secant. And as I look at my answer choices, they don't have secants in them. So I don't think we need to worry about going that route here. But again, just little things to be aware of. Multiple choice answers can often be rewritten with other trig functions, so just be careful, okay? In any event, we're happy with cosine xy. That's in all our answer choices. I'm going to subtract the y. And now I'll divide everything by x. Okay, and there's our answer. Now as we look, we don't see that exactly written that way. The answer's out there, but what we have here is a complex fraction. That's a little fraction within a bigger fraction. And the way we clean up a complex fraction is by multiplying by the least common denominator of our little fractions. So the only little fraction we have is this, and it's cosine of xy in the denominator. So I'm going to multiply the top and bottom of my original fraction here by cosine xy. Now let's see what happens when we distribute. Distributing to that, we're just going to get 1. Distributing to this, I'm going to get minus y times the cosine of xy. Distributing down to the bottom, I'm going to get x times the cosine of xy. And it looks like choice D it is. Okay, so again, Part of what makes the course tough isn't always the calculus, it's some of the old algebraic skills and geometry skills that you guys need to hold on to from 2-3 years ago. Okay, in the xy plane, the line x plus y equals k, where k is a constant, is tangent to the graph of the parabola y equals x squared plus 3x plus 1. What is the value of k? All right, well, look, let's think about this. The only place we even see the letter k is in this formula. That tells me we have to figure out a value for x and y that we can plug in there. If we can get a point xy, then we can plug that in and solve for k, okay? Well, what do we know? We know k is a constant, and we also know that this line is tangent to this parabola. Okay? And, well, what do we know about tangent lines? Well, we get the slope of the tangent line by looking at the derivative, right? Well, there's a connection to be made then. We actually have the equation of the line. Let's see what the slope of the line is by getting y by itself. So there's the line rewritten in slope-intercept form, and it looks like this line has a slope of -1. Well, this is going to allow us to solve for x. What do I need to do with the original function to find slope? Take its derivative. All right, well, let's do that. So there's the derivative, 2x plus 3. But we know the slope should equal -1. So we're not going to plug -1 in for x. We're actually going to take the derivative. We're going to set it equal to -1 because that's what the slope of the given tangent line is. So take the derivative, set it equal to the given slope, now solve for x. And it looks like x is -2. Okay? So back to this equation with k. We know x is -2. Great. We still need the y value. How do we do that? Well, let's go back to this other equation in terms of x and y. So keep in mind we have this parabola, and we have this line that's tangent to it. And what do the parabola and the line do? Well, they intersect, right? So they're going to have the same coordinates as each other. That means if I know that the x value is going to be -2, I can plug it into this parabola and get the y value that way. So let's see what y of -2 is. And I'm getting -1 if I'm doing this correctly. Okay, so y is -1 when x is -2, and if x plus y equals k, then let's see, -2 plus -1 is -3, and it looks like our answer is choice A. Okay, very tricky problem compared to some of the rest we've seen. Watch it a little bit, try and make those connections. Slope of the given tangent line is going to equal the derivative, and that's what we did here. Set the derivative equal to the given slope. Okay, the radius of a sphere is decreasing at a rate of 2 centimeters per second. At the instant when the radius of the sphere is 3 centimeters, what is the rate of change in square meters per second of the surface area of the sphere? Okay, so what did they tell us? Radius is decreasing at this rate. So I'm going to call that dr dt, and since it's decreasing, I'm going to call that -2 centimeters per second. At the instant, the radius is 3, so we know radius is going to be 3 centimeters. What is the rate of change in the surface area? And there's the formula. So we want ds dt, the rate of change of the surface area with respect to time. Okay, so taking the derivative, on the left we get 1 ds dt. On the right, we're going to get 8 pi r to the first times dr over dt. And I think we know both these pieces of information, so this shouldn't be hard. R is 3, dr was -2, and it looks like we're going to get -48 pi square centimeters per second. And there you have it. And here's one where you could probably get away with making a careless mistake and still getting the right answer. If you made that a +2, you would get +48 back. I'm surprised actually that's not an answer choice. Usually easy mistakes are answer choices. But given this exam, you know, if you saw that, you'd probably be leaning towards the negative, and hopefully it would click Y. Okay? But watch those negative rates of change. That's the point. All right, graph of f on the interval 0, 4, which of the following statements are true? The limit as x approaches 2 from the left exists. Well, as we come into 2 from the left, Yes, we approach some y value where the hole is, but that limit does exist, that's true. As we come in from the right, the limit exists, yeah. As I come in from the right, that limit approaches that value, that's true. But the limit as x approaches 2 in general exists. No, that is false, because the limit as x approaches 2 from the left did not equal the limit as x approached 2 from the right of this function. Okay, so 1 and 2 are true, but certainly not 3. Which of the following statements are true? 1 and 2 only. Okay, let f be the function defined by f of x equals 4x cubed minus 5x plus 3. Which of the following is an equation of the line tangent to the graph of f at the point where x equals -1. Okay, while these are all written in slope intercept form, I typically like to start using point slope form, which you may remember from pre-calc. x1, y1 is a known point. And of course, m is the first derivative, or slope, okay? So here, basically, to write the equation of the line, I need 3 values. I need to plug those in. They gave us the x value of -1. So that'll become a +1 in there. To get the y1 value, it's just the y value when x is -1. So I'll look at f of -1 to get the y1 value. And I'm getting 4. And the last thing we need is slope. That'll come from the derivative. So let's take the derivative of this function. And again, evaluate it at the x value of -1. And I'm getting a slope of 7. Okay, which looks good because a couple of these have slopes of 7, as we can tell. So I'm inclined to think we're on the right path here. And let's see what we get when we change forms. I'll distribute the 7. Just going to say goodbye to some folks. Bye, everybody. See you on Friday, I believe. Have a great week. And so adding the 4, we get 7x plus 11. There it is, choice C. All right. Can reach out with any questions there. But a pretty common kind of question. 24, if x squared plus x times y is 10, find dy dx when x equals 2. If you wanted to, you could get y by itself to begin. I don't think you should have to work that hard. In fact, if you do that, you're going to end up turning this into a quotient rule problem. I'm going to leave it the way it is, but since the y is kind of buried, I'm going to do this implicitly. So, from left to right, the derivative of x squared is 2x. Again, we have a little product rule here. Derivative of x is 1 times y, plus keep the x times the derivative of y. On the right-hand side, the derivative of 10 is 0. Okay. I'll work on getting dy dx by itself now. I'll subtract the 2x and the y, and I'll now divide by x. Okay, and now I want to figure out what this equals when x equals 2. So let's see, if I plug 2 in for x, we're going to get -2 times 2, but we've got this y still here. Okay, so I can go ahead and plug positive 2 in for x, but I also need the y value. Okay, so we still need this y value right here. So how do we do it? Well, here's the curve. Here's the x value. Not uncommon to have to plug one value back into the original curve to get the corresponding y value. So if I plug 2 in for x into the original, 2 squared is 4, plus 2y is 10, so 2y is 6. I guess that makes y 3. All right, so going back, we're going to have -4 minus 3 over 2 is -7/2, choice A. Again, watch those sneaky little products with the implicit differentiation, very common. And last but not least, we're given some values, f of 1, g of 1, so on and so forth. If h of x is f of x times g of x, find h prime of 1. This, again, is product rule. Okay, but we don't even have any actual real functions to sub in. We're just going to go through the product rule using the function notation. So it's going to look like this. H prime of x equals Derivative of the first piece, I'm simply going to write it as f prime of x times the other piece, g of x. Plus, now I'll take the derivative of that, I'll call it g prime of x times the first function, f of x. That's all there is to that. Now I can plug 1 in for x. H prime of 1 is then going to be f prime of 1 times g of 1 plus g prime of 1 times f of 1. And now we can grab all these values from above. Let's see carefully. F prime, it looks like, is -4. G of 1 is 3. G prime of 1 is -3. And f of 1 is 4. So what do we get here, folks? Not 0, but -24. All right. So go through these, look them over, and if you have any questions, please reach out before